Hello everyone, my name is Professor James Won-gi Hong and welcome to my lecture on Internet of Things, IoT. I'm a professor in the Department of Computer Science and Engineering at Pohang University of Science and Technology, POSTECH, located in Pohang, Korea. This lecture presents an introduction to IoT. I will briefly introduce myself and 4 industrial revolutions that are being mentioned a lot these days. I will introduce basic elements of IoT, its general architecture, and the technologies involved. I will present some examples or use cases of IoT that can help the audience to understand what IoT is all about. You can find useful references at the end that you can use to study further on IoT. Please allow me to introduce myself briefly. My education background since high school is from Canada. I joined POSTECH in 1995 as an assistant professor in the Department of Computer Science and Engineering. Since then, I had many interesting and valuable experiences, including co-founding a Silicon Valley startup in 2000 and working as CTO and Senior Executive Vice President of KT, Korea Telecom. So I have had many interesting and valuable experiences, and I'm here to share with you some of those experiences through the topic of Internet of Things. Before I talk about Internet of Things, let me talk about the 4 industrial revolutions. The core of the first industrial revolution, which started in the 18th century from Great Britain, was steam engines. These engines were powered by heating water by burning coal. This brought great efficiency in productions by changing manual productions to mechanical productions. The second industrial revolution came in the 19th century with the introduction of mass production assembly lines in Europe and America. It was possible through electricity, petroleum, and steel. Again, it resulted in ever greater efficiency and mass production. The third industrial revolution came in the 20th century with the development of electronics and information technology. The key aspect of this revolution is the automated production, requiring less human labor and increasing productivity even higher. Since a few years ago, we are considered to be in the era of 4th industrial revolution. The core of the 4th industrial revolution is the convergence of information and communications technology, ICT, incorporated with the Internet of Things, which is the topic of this course, artificial intelligence, AI, and big data analytics. IoT, AI, and big data have made intelligent productions. AI includes techniques and methods from machine learning, deep learning, computer vision, data mining, speech recognition, pattern recognition, and natural language processing. Now, let me introduce IoT. What is IoT? This is a sort of wiki definition of Internet of Things, or IoT. IoT is the internetworking of things embedded with software, sensors, and network connectivity, which enable these things to sense or collect data. And then these data are analyzed and then make some intelligent decisions. IoT allows things to monitor various objects, including human, animals, or some environmental conditions. It also allows things to be controlled remotely, providing convenience and improved efficiency. Things in IoT can be just about anything, including temperature, sensors, smartphones, CCTV cameras on the road, buses, trains, planes, and almost anything that we can think of. According to a survey done by Cisco, which is a global networking solution company, the number of things using IoT technology will increase from 14.4 billion devices in 2014 to 50.1 billion devices by year 2020. IDC, a US market research company, has predicted the global IoT market will grow from $1.9 trillion in 2013 to $7.1 trillion by year 2020. So in a nutshell, there will be an incredible number of things, and the IoT market will be very big. So if you're working in this area, well, you could be making lots of money. Now, let's look at some IoT services. At the bottom are the things or sensing devices, including home appliances, door locks, smoke detectors, and smartwatches. Then there are gateway devices or intermediate devices that exchange data with sensor devices and provide data to big data analytics servers in the data centers, which are then used by various IoT services, including home automation, health services, energy management services, and emergency services. Basically, all of these IoT services have a similar architecture. On the far left side of the slide, we have IoT endpoints, which are sensors, actuators, and aggregators. Sensors are devices that sense data. Actuators perform some actions, such as setting temperatures, shutting off switches, turning on lights, and so on. Aggregators aggregate data from sensors and send collected data to gateways. Then we have IoT infrastructure consisting of IoT routers or gateways. They interconnect with internet infrastructure to exchange data between the IoT devices and servers in the data centers. In the cloud or data centers, we have servers performing various actions related to data analytics. End user applications through smart mobile devices or PCs utilize these analyzed data. The human users may make some control actions through these client devices to perform some actions through actuators, such as making temperature settings on thermometers. Global cloud service providers such as Microsoft, Amazon, Google, and others have developed specialized cloud platforms called Cloud for IoT or IoT Cloud. They are basically providing the computing and storage services which are part of their cloud computing services. Plus, they are providing some sort of data analytics services for IoT. They typically collect data from sensors or gateways, perform various analysis, and make some actions and/or store the results for later use. Microsoft Azure IoT Suite, Amazon Web Services IoT, IBM Watson IoT, Google Cloud Platform, and Samsung ARTIK Cloud are examples of these. There are many communications technologies used in IoT. They are mostly wireless networking technologies, personal area networks, PAN, technologies are used to exchange data in very short distances. Bluetooth, Zigbee, Z-Wave, NFC, RFID are major examples of personal area networks. Most of us are very familiar with Bluetooth, which is used to communicate devices such as wireless speakers, microphones with our smartphones. NFC, or near field communication, is a technology also used to open doors and make payments using our smartphones. Wi-Fi and PLC, power line communications, are examples of local area networks. PLC uses part of our electricity network bandwidth to transfer data. We're very familiar with Wi-Fi as we use quite frequently to connect to the internet from our smartphones or laptops. Mobile wireless networks such as 2G, 3G, LTE, mobile WiMAX can be used to exchange data between devices and gateways. LoRa, NB-IoT, Sigfox are mobile wireless networks that have been developed recently specifically for IoT. Telcos have begun to deploy these IoT networks nationwide around the world. In Korea, SK Telecom has deployed LoRa, and KT and LG Plus are deploying NB-IoT. There have been numerous industry forums that have been trying to standardize communication protocols among the devices in IoT. Many have merged and disappeared. As of this lecture, two dominant industry standard forums exist. They are OCF, Open Connectivity Foundation, and 1M2M. OCF focuses on interoperability of home appliances. Until 2016, there were two separate groups, one led by Samsung and another led by LG. Until now, when we have appliances, for example, TV and refrigerator from Samsung, and some others, such as washer, microwave, dishwasher from LG, these devices do not talk to each other. That means one could not monitor or control these appliances from a single mobile application. Now, they will be changing. At the end of 2016, those two separate industry forums have merged into a single industry standard forum called OCF. They are expected to demonstrate interoperability of appliances from Samsung and LG in the fall of 2017. Another famous IoT standard organization is called 1M2M, which is driven by telcos and telecommunication solution vendors from around the world. It tries to standardize cellular communications and related technologies for telco-related IoT applications. There are a few terms that are similar to IoT. USN, Ubiquitous Sensor Networks, has been around for more than 10 years. M2M, machine-to-machine, has also been around for a similar length. Recently, IoE, Internet of Things, or Internet of Everything, Cloud of Things, Web of Things are also being used. Although the terminologies are slightly different, you can think of them as same. They all try to achieve what IoT is trying to do.